Okay, so this is the last day that we will work with 1.5. So I know it feels like we've been stretching this out forever.
On the quiz thing, I'm still on
Oh, okay. On Friday I gave you that peak function chart, right? And I told you that very right column, you're not going to know what it is, or I meant to. I can't remember if I did that in the first hour. But that very right column, even and odd, we haven't talked about that yet. Guess what? Today we're going to talk about it. So after today, you'll be able to fill out everything except the very last row, which is the greatest integer function, and we'll talk about that one tomorrow. But what is an even and an odd function? Okay. So we are going to talk about with each of these what it means algebraically and what it means graphically. The graphical part of it is going to be the easiest to determine. The algebraic part is going to be what we're going to need to work on here in class today. Okay? So we're going to start with even function. An even function. The algebraic definition is that we have an even function if f of negative x equals f of x. Write it down and then we'll process it. So our graphical definition is going to be based on symmetry. So if f of x is equal to f of negative x, where are we going to have symmetry? If we put an x and we get a y value, we put a negative x and get the same y value, where are we going to have symmetry? Over the y-axis, Max says. What do you think? If I plug in x and get a y value, I plug in negative x and get the same y value, we are going to have symmetry with respect to the y-axis. Okay? So this is an even function. I can look at the graph and tell that it is an even function. Okay? Which, if you've graphed any of those parent functions on your pink chart, you can just look at it. Is there symmetry about the y-axis? Cool. It's an even function. For an odd function, I didn't know that could change colors, but it did. Don't know what I did. Probably won't be able to do it again. For an odd function, our algebraic definition is that, be careful with all of these negatives, f of negative x equals negative f of x. Write it down and then we'll process it. Okay, so let's just imagine I have a coordinate x, y. What this is saying is if I take an x value, I throw in its opposite, then I'm going to get the opposite of y. So what coordinate, or where would our coordinate be? Quadrant 1, 2, 3, or 4? I throw in the opposite of x, and we get the opposite of y. It's going to jump into the third quadrant, which means we are going to have symmetry with respect to the origin. Okay, so we're going to have like that first to third quadrant or second to fourth quadrant symmetry. Okay, so on your pink chart, if you have a function that has symmetry with respect to the origin, you can say that it's an odd function. Those of you who have maybe looked at your parent function chart, who can give me one function that would have odd symmetry?
Cubic. When f of x equals x. So like that unity function.
Okay, good. So you said f of x equals x, and Riley, did you say a cubic function? Those both would be odd functions because they have that symmetry about the origin. Okay? Now, what I really care about is that you can prove to me algebraically that it is odd or even. Now, does a function have to be odd or even? It is possible that it's neither. Probably more likely that it's neither. These are very special cases, okay? So we're going to go ahead and do this one first. I'll show you what I expect with these problems, what I need you to show me. So f of x equals 4x squared minus 2. And some of you might even have an idea right now of what you think it's going to be. All right? And that's fine. But when I ask you to show me algebraically, I need to see some algebra. Okay. So what we need to consider, is it even or is it odd? Okay? Well, if it's even, I'm going to come back to here. If it's even, then f of negative x needs to equal f of x. If it's odd, f of negative x equals negative f of x. So there's three things we need to find. We know what f of x is. We need to see what f of negative x is. If those are equal, then we know it's even. If they're not, well, down here, f of negative x would need to be compared to negative f of x. And so then if those two are equal, then we're on. So let's just go here. We know that our function is 4x squared minus 2. So our first step would, let's see if it's even. Okay? And if it's even, then we would need to determine what f of negative x is. So f of negative x means we throw a negative x anywhere there's an x. And what happens when we take negative x and we square it? Okay, that negative disappears, right? So we get f of negative x equals 4x squared minus 2. So my first question is this the same as f of x? Okay, so what I would need you to write is that this is even and how you know it. Okay, we just showed that f of x equals f of negative x. Now, if you write that without the blue work, I'm not accepting it. Okay, I need to see that you algebraically considered what f of negative x is. Okay, so some of you may feel that I'm asking you to do more work than necessary, but I'm asking you to prove algebraically, which means we need to show all the steps. Yeah.
So obviously most calculus stuff is going to be symmetrical on the y-axis. So if there's a horizontal translation, does that not mean?
Right. If there's a parabola that's been translated horizontally, Probably not gonna have that symmetry, which means algebraically you should find that nothing works, okay? So you know what to look for, but you still have to do the algebra if I ask you to prove it that way. Does that make sense?
Yeah.
Okay. Did everyone hear his question? Okay. So let's do one that's not even to see what happens. I've given it away that it's not even, but that's okay. I want you always to start with looking to see if it's even. Okay? So we have f of x equals x squared minus x minus 6. Let's first take a look at f of negative x. Make sure that when you plug into a function, you do so using parentheses. Okay. So what happens is we have, well, negative x, the quantity squared, goes to x squared. Minus negative x turns to plus x, and then we have minus 6. Are f of x and f of negative x the same? Okay. So we know that we don't have an even function. I told you that, but now we officially know. Okay. So now we need to look to see if it's odd. Okay. Well, for an odd function, f of negative x would need to look the same as negative f of x. Okay. All we have to do for negative f of x is take the function, put it in parentheses, and throw a negative out in front. We're negating the entire function, negative f of x. So when we carry that through, negative x f of x would be negative x squared plus x plus 6. Are f of negative x and negative f of x the same? Okay, so I do want you to actually write that you look to see if these were equal and they weren't. I want you to write these two that you considered if they were equal and they weren't. And then we decided that it was neither. So this is probably the most intensive algebra that we've talked about as far as chapter 1.5 is concerned. We've done a lot of graphical analysis. Here's some algebra for you. Okay. Before we go on, are there any questions about the algebra up there, or would I expect you to write? Yeah.
On our pink sheet, do you want us to prove it?
On your pink sheet, you can just look at the graph. Okay, that's a good question. Just look at the graph. In your homework, I'll ask you to prove algebraically. And that's probably what we'll start the day with tomorrow, is doing one of those in classes, like a warm-up problem, to make sure we have the process down okay. All right. Now, before we get to play with our calculators, I want to talk about what a minimum and a maximum is. So this graph should look familiar to you. I think we talked about this Thursday when we did increasing and decreasing intervals. Okay. So I'm going to give you about 30 seconds to discuss with your pod which coordinates up there could be one or more. Where would we have a relative minimum? Where would we have a relative maximum? Just see if you can kind of figure out what that would be based on the name. Talk about it. Yeah.
Yeah, but this is more.
We've got some good conversations happening. Addison, give me a coordinate that pod 8 decided was a relative minimum.
3, -3.
So 3, -3 you decided was a minimum. And why did you decide that?
That's the lowest point.
Okay, great. A relative maximum. Addie, what did you decide? What did your group decide?
0,
And why did you say that?
because it's like the highest.
Okay. Are there any other minimums or maximums? Max.
Like infinity being one of the maximums. Does that like keep going?
No, because infinity is not actually a value. We just know it's going to continue to rise. But I like where you're thinking. I like how you're thinking. Anybody talk about any other coordinates? I heard someone ask about this one right here. Did anybody talk about that coordinate? Okay. It is actually a relative minimum. Relative means it's the lowest point in an area, not in the entire graph. If I asked you for the very minimum, I would want the lowest point. But a relative minimum is just in a relative area. So relative minimums are going to happen when you have a change from decreasing to increasing. Okay, like we do here, we go decreasing to increasing, there's a minimum. And then vice versa for our relative maximum. All we need is a change from increasing to decreasing, and boom, we have a relative maximum. It doesn't have to be the highest point, it just has to be a high point for that part of the graph. So a change from increasing to decreasing or vice versa is how we're going to identify relative minimums and maximums. Okay. So they don't have to be the highest or the lowest. All right, so we need our graphing calculators out. I'll get mine out. Where is it? Here it is. You have one. You do have one? Can I have one? You don't. Okay. Are you good? Okay, so you can borrow that for today. Who else needs one? For today? You will be in front. Okay. Anyone else? The calculator answer you have? That is not a graph one. Okay. So I'll let you use that. Is your graph? Oh yeah, that is not graph. Okay, so I'll let you use that today. Okay, so I want everyone to turn theirs on. Okay? I want everybody to go to mode, and just in case, I want you to make sure it's in function mode. If you're borrowing it from a sibling, they might have it in like a parametric or polar mode, and I don't want that for you. So just make sure function is highlighted. Yeah.
Can I get one? I don't know.
Just hit enter. Yeah. If it's highlighted, you're fine. If you want to highlight it, then it needs to say enter.
Wait, what? So
Just make sure function is highlighted.
Oh,
Okay, how many of you are borrowing yours from an older sibling? Okay, fair enough. All right, now I want everybody to click y equals. I want everybody to hit y equals, and you get a bunch of y equals. Please look up here. Do you see where it says plot 1, plot 2, plot 3? If those are highlighted, you cannot graph. Does anybody have theirs highlighted, like they're black, instead of like mine? Okay, then arrow up and hit enter so the highlight comes off. If your plots are on, you cannot graph. Okay. Are you guys excited? No? What? Okay, so this is the function that we're going to graph. So what you need to do is just type in x minus 2x plus 3. X times x minus 2. Hold on. Let me just get it typed in so you can see it. Okay, so here it is, the X button. Do you see this right here? It says XT theta N. Anytime you press it, it'll give you an X. Okay. Parentheses are right here above 8 and 9. And if you hit the graph button, it'll give you the graph. If you hit graph, oh, do you see how mine's all wonky? Okay, if yours isn't that 10 by 10 grid, then if you go to this button here, zoom, and 6 is standard, zoom 6, it'll get you back to that 10 by 10 grid. So if you ever like zoom in, zoom out, zoom 6 will get you back to square one. If you want to get the same answer. Now, here's this button right here called trace. If you hit it, you can arrow like back and forth on your graph, or if you hit like 2, enter, it'll give you the coordinate for x is 2, or 3, enter, it'll give you the coordinate for, see, it'll give you the coordinate 318. Okay, so that's kind of fun. So here we're at 0, 0. Now, do you see a relative minimum on that graph? Yeah. Do you see a relative maximum on that graph? Okay. We are going to use our calculator to figure out where that is. Now, yes, we could like toggle back and forth with our trace button, but that's not going to be very accurate. Our calculator can be very accurate. So, I'm going to teach you how to do that. If you would, please hit second, that second button, and then up here, trace has a little calc above it. So if we hit second in the trace button, we're going to a calculate menu. Okay, I've kind of alluded that we're going to calculate what? A minimum. We'll do a maximum as well. Okay, so go ahead. You can either press the number 3 or you can arrow down and hit enter for minimum. Yeah, so hold on. Just hold on. Is everybody to where we are? I think that our minimum is right here. Do you? Okay. So some of you have already seen this. It says left bound. That means it wants you to get your cursor just to the left of where you think the minimum is. So if we think this is our minimum, I'm going to arrow over until my blinky dot is to the left of it. And I'm going to hit enter. Okay. Now it asks for right bound. So I'm going to toggle to the right until I'm on the right side of where I think that minimum is. And I'm going to hit enter. And it says guess. Just hit enter again. And then it'll give you the coordinate of the minimum.
That's an error, and then kind of looked like it left.
Okay, so that maybe you didn't get it all the way to the left or all the way to the right. So, okay, so we're gonna do the minimum. So here we're to the left. Here to the right. Yes. I'm guessing when yours was to the left, you didn't get it quite over to the left. Okay. All right. So what I'd like you to do is find the maximum for me. So go to your second calculate menu, and this time you're going to choose maximum and do the same process. Let's see what we can do here. And I'm coming around to help you. So this is a negative sign. Okay, so there is a difference. Okay, so I'll have you go. Here, I'm gonna get this. So if you need any of those instructions in words instead of me talking, there's the word instruction. Did you find that?
Sorry, I think
So I'm getting this training again all the way to the left or all the way to the right. So
I was so sad. I was like,
okay, so you're on the left side. So now make sure you toggle all the way until you're on the other side of the hump. Or you're okay.
like I actually just like get up.
So there it is. Okay.
It's like, you know,
Anyone else having trouble?
every day, so-
You get it? Good.
Yeah.
Over here? You get it? Here we get it? Over here? Nate, did you get yours okay? Okay. What over here?
I went yesterday. I literally went back here and
Oh, okay, so yep, there's just one right there. Okay. All right, very cool, very cool. Now, I'm going to teach you how to find zeros. So, let's practice. I want you to put in a new function for me. So, go to y equals and clear out that first one. We don't need it anymore. And go ahead and type in 3x squared plus 22x minus 16. Now, if you have a calculator that has like the different colors, if you want to go to a different color and enter this in, like by all means you go for it, but it really doesn't mean anything. Okay, we're not finding maximums or minimums this time around. So 3x squared plus 22x minus 16.
I did this.
3x squared, is it plus 22x? So does yours look like, whoa, okay?
Yeah.
So if we zoomed out, we'd be able to see the parabola. But I really don't care about the parabola in terms of like where the vertex is. I care about the zeros. I'm going to teach you how to find the zeros. And zeros mean we're looking for where it intersects the... No, it is an intercept. You said x-axis. I processed what the word was when you said, yep, we're all right, okay? So we need to look for these coordinates right here. I'll help you find one, and then you'll do the other one by, oh my God. Second, calculate, 0. And then you're gonna do the same thing, left bound and right bound. So my cursor, where is it?
You even see my.
Yep. Watch your Y values. Okay, here it is. So I'm on the left, I hit enter. I'm on the right, I hit enter. And then I guess, and it gives you the 0.
With the left of what?
Just the left of the intersection. So if this is my 0, I want to be more negative for the left, more positive for the right. Who had their hand up? You forgot your X. So you need to go to the left would be more that way. Yep, so hit enter. And then okay, so do what you can on your assignment. Okay, you have a book assignment. If we need to go over this again tomorrow, we can, but just try it. I'll leave the video still recording, so if you need to go back and look at those instructions. Those of you who borrowed a calculator, come return it to me. If you need to check one out, I'll give you something to fill out.